Leverage assortment of Microsoft technologies. Marching onwards in the battlefield of grid computing, the collective utilization of Microsoft Windows, Microsoft.NET Platform, Microsoft SQL Server, and Alchemy.NET based grid technologies to harness the power of desktop workstations to structure a compute grid. Business organizations have terabytes of data and are collecting more data every day. Petroleum companies have seismic data that may help improve production or identify new reservoirs. Auto manufacturers have engineering data that might make new car designs safer or less expensive to build. Life sciences companies collect terabytes of data that may contain the key insight leading to a new treatment. To solve all these emerging problems is itself a problem. For example, a human body contains more than 3 billion genes, and the complete sequence of the genes is called human genome. Microbiologists are trying to translate real genome into the language of bits and bytes. This all information translation needs ample of computer resources to store and solve terabytes of complex data. Besides, to simulate nuclear reactions and proliferation process outputs trillions of bytes. Similarly, weather forecasting or climate modeling, aircraft modeling, and other CPU-intensive applications require higher performance computing platforms. High-performance computing is an essential tool of contemporary scientific research, providing a powerful means of directly extracting the traditional methods of experimentation, theoretical analysis, and modeling. High-performance computing, perhaps more commonly called supercomputing, enables the researcher to analyze and understand complex data in many ways, particularly in the visualization of such information. These hardware considerations are based on the low cost and effectiveness ratio. Low-cost commodity clusters provide low cost and greater magnitude for scientific solutions and is thus effective for task-dedicated problems. Clusters use low-cost hardware, open-source software, and provide cost-efficient solutions. There is rapidly emerging interest in grid computing from commercial enterprises. The Microsoft-based Windows grid computing infrastructure will play a critical role in the industry-wide adoption of grids due to the large-scale deployment of Windows within the enterprise. This enables the harnessing of the unused computational power of desktop PCs and the workstations to create virtual supercomputing resources at a fraction of the cost of the traditional supercomputers. However, there is a distinct lack of service-oriented architecture-based grid computing software in this space. To overcome this limitation, we have deployed a Windows-based grid computing platform called Alchemy implemented on the Microsoft.NET platform. While the notion of grid computing is simply enough, the practical realization of grids possesses a number of challenges. Key issues that need to be dealt with are security, heterogeneity, reliability, application composition, and scheduling and resource management. So far, various grid-enabled paradigms are being developed to carry out large-scale problems in various fields of science, engineering, and commerce. Traditionally, Unix Linux class operating systems are mostly used since the grid-enabled software is written for open-source systems. This could be beneficial for dedicated clusters of organizations, yet it results in intensively limited ability to effectively utilize the computing resources since greater part of desktop computer users run various flavors of Microsoft Windows operating system. Imagine a world which inhabits 100 computer geeks. 6 of them would be using Linux, and the rest of the other would be using Microsoft diverse technologies. Microsoft outperforms excellent results and affects mass number of users deeply as well as broadly, thus leveraging Microsoft technologies to harness a greater magnitude of computer resources in the form of a gigantic computer grid.